Three-phase autotransformers. In this presentation, we're going to be looking at how autotransformers are used in the electrical industry, and we're going to start with why we would want to use them. Then we're going to look at some three-phase autotransformer configurations. What are the standards out in industry? Then we're going to look at some different options for either purchasing or assembling autotransformers that are three-phase. And then we're going to take a look at the very odd Zigzag autotransformer at the very end. Well, autotransformers are able to carry much higher load kVA compared to isolation type. This is considered to be a good side effect. Autotransformers are therefore much smaller than isolation type transformers for the same kVA rating. This is also good. Autotransformers offer no isolation from primary to secondary circuits. And unfortunately, this ends up being kind of a bad side effect of using an autotransformer. The lack of isolation means that extremely high fault currents can be supplied to the secondary circuit. And also, if a winding were to break an autotransformer, it could, depending on the winding, lead to a huge voltage across the load. As we see here, if we had a broken winding on an isolation transformer on the secondary, well, not much of consequence would happen. You'd have 0 volts across the load. However, on an autotransformer, if we had a broken winding, well, now we would have the full 12 kV applied across the load, and you can bet it probably will not be able to withstand that potential. Now, due to this, autotransformers are restricted to very specific installations that do not supply interior building wiring systems. So what I mean by that is running power from one of these transformers to all of the lights and receptacles inside a building. This is typically not done because of the very high fault current values that we can expect. Where you would see these would be on multi-tap transformers for high bay or HPS lighting ballasts. This is what it would look like for those of you actually doing the installation. You just have a bunch of flying leads and you hook up the voltage that you have available. Variable voltage supplies, these are both single phase options at this point. When it comes to three phase, we have a few different items that are commonly used with autotransformers, and that would be individual equipment. So we have a piece of individual equipment that comes in from a different country. It's three phase, but it does not have the same line voltage. Instead of supplying this piece of European equipment with a isolation transformer, we can far less expense install an autotransformer and supply the equipment. And finally, reduced voltage starters for three-phase motors. We're going to look at some autotransformers that are three-phase that would be used with this type of installation. Now there's some pretty standard autotransformer three-phase configurations. We have Y, delta, extended delta, and open delta. Y and open delta being the most common, and I suppose between those two, open delta is the absolute most common. This is an example of a Y autotransformer, and what you can see is that there is H and X terminals, and there is no isolation from primary to secondary. The H terminals are going to be at the end of a single winding, and the X terminals will be partway along because it's a lower voltage to the star point. There's lots of different diagrams and orientations that we can potentially see. This one's a little bit more confusing. I don't really like this one. And here we are with the actual connections. Now I've neglected to put in any of the neutral connections on this, and it is very much dependent on the type of system and type of load if we would use the neutral star. But as you can see, for the basic connections, we have X1, 2, and 3, and H1, 2, and 3 connecting to the high and low voltage. Now, Y autotransformers typically have a tertiary winding that has no external circuit connections. Now, this reduces harmonics in the system, and really it's not even something that's on the nameplate, nor would you be able to easily identify on the transformer itself. It's really, there's no connection to it, so they don't even really provide any info. This particular Y auto transformer has a number of different tap locations, allowing for a number of different input and output voltages. We can see at the top 600 or 480 volt three phase, and then you have a option of 208, 240, or 400 volt three phase on the secondary. A delta auto transformer is very similar, however, it is rarely used. It's usually a larger size when compared to a Y auto transformer. It doesn't really have a massive transforming ratio, and again, it has this tertiary winding. So delta, we don't really use too much. Along with the extended delta auto transformer, I can't say I've actually seen one of these ever or seen one advertised by a manufacturer. So we're not going to spend much time on this one either. The open delta, however, is the auto transformer that probably has the most recognition when it comes to three-phase auto transformers. It's commonly used due to the reduced equipment requirements, as there's only two windings as opposed to three. Here's an example of a manufactured open delta auto transformer. Now, three-phase auto transformers come in three different options. We could, of course, purchase a manufactured three-phase auto transformer. We could assemble a three-phase auto transformer with single-phase auto transformers. And finally, we could assemble a three-phase auto transformer bank with single-phase buck boost isolation type transformers. Oh, it's quite a mouthful. Let's take a look at each one individually. Here's an example of a manufactured three-phase auto transformer. Other than the nameplate, you really would not be able to recognize any difference in the outside dimensions or the construction of the enclosure of a three-phase auto transformer. It's not until you look at the nameplate that you would then see. On the actual connections, again, we really don't have much difference when it comes to the actual terminations. We're going to have X, Y, X terminals and H terminals. And other than the weight of the unit, we really won't be able to tell that this was a auto transformer versus an isolation type transformer. Instead of having a high and a low voltage winding here for A, B, and C, there's actually only a single winding. One single winding here, a single winding for B, and a single winding for A, hence the non-isolation or auto transformer. So the other option would be for us to assemble a three-phase auto transformer bank with single-phase auto transformers. Now this also is done quite commonly, and it's not too terribly difficult in order to wire up. This is an example of a fairly small, it's a 5 kVA wall mount auto transformer by Beaver Electric. They're out of Burnaby, BC. And what you can see is that we've got a 0 terminal here, 208, 220, 230, 240. Now, if I have three of these transformers, I can connect the windings together so that I make an open delta. You can see here, this is what the inside typically looks like. It's usually an encapsulated sand resin mixture, and they just have leads that are coming out that are identified with the voltage number. So if we had three of these, we could hook them up in Y or in open delta if we only had two. Finally, the last option would be if we used single phase isolation type buck boost transformers. And these are considered to be the workhorse or the jack of all trades transformer because of all the different orientations it can be connected in, rendering all sorts of different voltage input and voltage output. So a buck boost multi-winding isolation type transformer is one that obviously has isolation between the primary and secondary, but is actually designed and intended to be connected not only in isolation, like we see here, where the primary could be in series or parallel, and the secondary could be in either series or parallel. but also in auto, meaning we have a myriad of different voltages available to us for both input and output. And so the manufacturers take this into account and provide additional diagrams that show how this transformer could then be connected into a three-phase auto transformer bank with either a Y or an open delta formation. Here's a few of the diagrams from this particular manufacturer showing how we would do this connection. We're seeing here a busway or a wireway where these leads are being connected together, and it looks like they're doing a Y auto transformer bank. And we can see here there's a bunch of different Y and open delta orientations. So lots of different options when it comes to auto transformers and how they could be used with single phase buck boost transformers that are just off the shelf. So we'll take a look at these in a later presentation with some calculations. Finally, three-phase auto transformers or zigzag three-phase auto transformers. They're also known as zigzag grounding transformers or zero sequence transformers. Now, a three-phase auto transformer that has no secondary winding is what a zigzag transformer is. There's four connection terminals, and the HO connects to a resistor, which then goes down to a ground electrode. This type of transformer is not used to transform voltage from a primary to a secondary step down or step up. There is no isolation. It is obviously a auto transformer, but it's used for grounding. Again, the actual form visually of this zigzag transformer would not look any different from any other transformer until you looked at the nameplate. This type of transformer is used for artificial grounding in ungrounded delta systems, which we'll discuss in a little more depth in a later presentation. What it allows for is the connection of the ungrounded conductors in the delta system to have a path back if there is a fault. And by doing this, we allow for a reduction in the spiking voltages that can take place when we have a fault on an ungrounded system, as well as reduce some of the harmonics that are sometimes generated. So due to the winding orientation on the transformer, the magnetic flux interactions cause an equal distribution of the fault current to each of the three phases. So kind of an interesting application here. And so we can see without this isolate or this zigzag transformer, this connection to ground or accidental fault would not have any current flowing and would instead cause a series of spiking voltages that could start to degrade or destroy the insulation on the conductors. So can help reduce unwanted harmonics and voltage spikes in ungrounded systems. And we very commonly see these used for wind generation grounding because those are usually an ungrounded supply. And so we can see on some of the diagrams, they'll show a grounding transformer and this sort of odd star or zigzag type formation.